Now, this is some Waec past questions, theory questions regarding Boyle's law and Charle's law. The first question here, 1A, is Waec 2009, question 2. It says state Boyle's law. And we already know that Boyle's law states that the volume of a fixed mass, of gas is what? Inversely proportional. Inversely proportional to the what? To the pressure. At what? At constant what? Constant temperature. What does it mean to us? You know, when we use this word, inversely proportional, and we are comparing two variables, we mean that the first variable is inversely proportional to the second variable. We mean that as the first variable is increasing, the second variable is what? Reducing. That's inverse. A number is 2. The inverse of that is what? 1/2. Are we together now? So it means, for example, now, if I blow air inside the balloon, so I can calculate the volume, or the volume means what? The space that the air inside the balloon occupies. Am I talking to you? If I want to change that volume now, the initial volume, that's V1. If I now take my hand around the balloon, I now press it. Before I press it, the balloon is originally experiencing a pressure from the air. We call it atmospheric pressure, which is equal to 1. But by the time I now use my hand to cover the whole body of the balloon and now press it inside, I'm increasing the pressure from 1 atm maybe to 5 atm. So I'm getting the second pressure, which is P2. As I'm increasing my pressure, the size of the balloon, which represents the volume, is getting what? Reduced. So you can now say what? That the pressure is inversely proportional to the what? To the volume. So just like we said that it states that the volume of a fixed mass of gas is inversely proportional to pressure, you can still say that the pressure of a given mass of gas is inversely proportional to the volume. You are still correct by saying that. So now, why did they not say at constant temperature? If the temperature must be kept constant, not increasing. Because if I perform that experiment, I try to use my own hand to cover the body of the balloon as I am pressing. If I now take it outside where the temperature is increasing of the sun. Now, according to kinetic theory of gases, the particles of gas inside the balloon, they will have increase in kinetic energy, that is energy at motion. They will now begin to move faster, colliding with the wall of the container from inside, pushing my hand away. As they are colliding with the wall of the container, the volume will be what? Increasing. And as I'm trying to press it inside, they are pushing my hand away. They will make that law of Boyle's law to be what? Frustrated. And that is why they say, let temperature remain what? Constant. Are we together now? Not increase. Don't go and do it in a place where the sun is shining. Or are we together now? That is why. Then here they say, give the mathematical representation of Boyle's law. You can say the volume is inversely proportional to pressure. You now say T equals to what? Constant. Then tell us that V equals to volume. Tell us that P equals to what? Pressure. Tell us that T equals to what? Temperature. Then you have answered this question. Do you know that you can still say the P is inversely proportional to volume? It's still the same thing. Oh, okay. You can now go ahead and say what? V, this thing will now change to equals to, then you introduce a constant K, then times what? 1/P. Then you can go ahead and say V is equal to K over that, K over P. Then our K, when you cross multiply, this is over 1 times 1 will now become what? Vp. Then you have answered this question. Then the next question says we should sketch a graphical representation of Boyle's law. Now, there are so many ways you can sketch it. You can sketch something like this. Let this one as it represent pressure. You can put, and let the SI unit is millimeter mercury. That's not the only SI unit of pressure we have. You can also use atmospheric pressure, ATM. You can also use Newton per meter square. Then at this side, we have what? Volume. And the SI unit of volume we want to use here is what? CMQ. We still have DMQ. Now, what we are telling us here is that if the thing we start, we begin from, it will be like this. What does that mean? It means that if we follow this table, for example, if this is volume, this is pressure. If this one is 1, 2, 3, 4. This one will be 4, 3, 2, 1. You can now see here, as volume is 1, pressure is at its maximum. So if the volume increases from 1 to 2, pressure will reduce from 4 to 3. As the volume is increasing from 2 to 3, pressure is reducing from 3 to 2. So we can now say Boyle's law, and the volume is inversely proportional to what? To pressure. Are we together now? So if you plot a graph like this, you are telling us that, okay, let's say this one is 1, 1, 2, 3, 4. This is 1, 2, 3, 4. So if you trace this one to this curve, it will meet at what? 3. At low pressure, let's say this is pressure, this is volume. At lowest pressure, very high volume. Are we there now? So as we increase this thing from 1 to 2 to touch here, this one is reducing from 3 to what? To maybe 2.4. Are we there now? As we increase this one from 2 to 3, what is happening to this thing? It's reducing from this 2.3 to 1 point something. As we increase this one from 3 to 4, this one is reducing now to what? To 1. Can you see that now? That is why the graph is this. You can still use this graph as this, or you can still say volume in what? Centimeter cube. Then inverse of pressure, which is what? Millimeter mercury inverse. Then the graph will be like this. It will be a straight line graph. What does it mean? We can say that Boyle's law states that the volume of a fixed mass of gas is directly proportional to the inverse of pressure. Just like we have here, the volume is proportional. This is the sign for proportionality. To directly proportional to what? Inverse of pressure. If pressure is P, the inverse of it is what? 1 over P. Because that P means P over 1. Are we together? Inverse, like this is the opposite. The 1 come up. So the same thing is here. If I have here, I hope you have your calculator there. Calculate for me. 1 over P here. 1 over 4 will be what? What will be 1 over 4? 0. What? 0.5? 25, Abby. Now, what is 1 over 3? 0.33, Abby. What about 1 over 2? That's 0.5. Then 1 over 1 is what? 1. Now, you can see as the volume is increasing from 1 to 2, the inverse of pressure, what is happening? It's also increasing from 0.25 to 0.33. Am I talking to you? And the volume is also increasing from 2 to 3. The inverse of pressure is increasing from 0.33 to 0.5. Are we there now? So that's how we say that the volume of a fixed mass of gas is directly proportional to the inverse. That is, as volume is increasing, inverse of pressure is also what? Increasing. When it is inverse. So that's why we have something like this. So if we have something like this, and we put something like this, let's say this is 1, 2, 3, 4. This is 1, 2, 3, 4. So if from this is 1, if I try it to touch this curve, it will also touch 1. So if I increase from 1 to 2 to touch the curve, this one will also increase from 1 to what? To 2. If I increase from 3 to what? 2 to 3. This one will also increase. Are we there? So that means this one is P, this one is 1 over V. Or this one is what? V, this one is 1 over V. Are we there now? So this curve is still what? Very much correct. That is, if the pressure is inverse, or you put pressure here, you put 1 over volume here. Are we together now? So the second question is saying the table below gives the volume pressure data for a particular sample of a gas at a given temperature. We have volume in dm cube. You know, I told you the unit of volume can also be in dm cube. You have pressure in atm, atmospheric pressure. Then when the volume was 400, the pressure was 1. When the volume now decreases from 4 to 2, this one increases from 1 to 2. Can you see that now? And this one decreases from 2 to 1. This one increases from what? 2 to 4. You are blocking them. Now, here now they now say deduce a mathematical relationship between volume V and P, pressure P. So what do? You already know that as volume is reducing, the pressure is what? Increasing. So you now say, okay, volume is inversely proportional to pressure. Are we there? At what? T equals to what? Constant. So you now say V equals to what? Volume. P equals to what? Pressure. Then T equals to what? Temperature. I don't want noise. So. Now, then the next question says, name the law that can be deduced from the table. What is the law? Can somebody tell me? Boyle's law. Now, he said, calculate the pressure. We are looking for pressure. When the volume, we are still using this table. When the volume is 3.2. Do we have any 3.2 here? No. Are we there? So I can choose this 4 as my V1 to be 4.00 dm cube. Where did I see my dm cube is here? Are we there now? Now they say I should find what? Calculate the pressure of the gas. When the volume is no longer this one, that's V2, is now what? 3.2 dm cube. Are we together? I've got it. So as at the time when V1 was 4, what was P1? P1 was what? 1.00. I mean ATM. Am I correct? Now what am I now looking for? Calculate the pressure. I'm looking for P2. I don't know it. I want to join to this table now. You know, when the volume is now 3.2, that is in between this place and this place, they say I should create I want to create, that is what it means now, another space here. So that here now, the volume will not be what? 3 point what? So what will I put here? That's what they are asking me. Are we together now? I don't know this place. Are we together now? And I know that this is my first volume, V1. I know that this one is what? My first pressure, which is P1. So what will I now do? I'll now say, what is the formula? We already calculated that. We already say K equals to Vp. So the formula for calculating Boyle's law calculation will now be V1, P1 equals to what? V2, P2. Are we there? What am I looking for? P2, Abi? Divide both sides by what? V2. I have V1, P1 over what? Over V2 equals to V2, P2 over what? V2 that is standing with this. So this one cancels. So my P2 will now become to V1, P1 over V2. So substitute your value. Now my V1 now is what? 4. My P1 now is what? 1. Now what is my V2 now? 3.2. So my P2 now will now become to 4 over 3.2. What's the calculator there? Press please. 1.25. What's the unit? ATM. So here now I should have what? What do I have there? 1.25. You can see 1.25 is still bigger than 1. Yes. So 1 increased to 1.25. From there increase to 2. Then increase to 4. Can you see that now? Yes. So that is that. Then I come back here. They say state Charle's law. We say the volume. Okay, Charle's law states that the volume of a fixed mass of gas is directly proportional to what? To temperature. At what? Constant what? At constant what? Pressure. What does that law mean? We are in Boyle's law. We were comparing volume and what? And pressure. Now, in Charle's law, we are comparing volume and temperature. Just like the experiment I demonstrated to you now. You put air inside balloon. Don't press it. If you are pressing it, you are proving Boyle's law. Just go and put it outside, where the sun will shine on it. After some time, what happens? It will burst. What makes it burst? Charle's law has happened to it. Because, now, as the sun is shining, the temperature is what? Increasing. Are we there now? As the temperature is increasing, the kinetic energy of the gas inside the balloon is what? Increasing. So this will now be making the particles of the gas inside the balloon to do what? To be colliding. The particles of the gas inside the balloon will now be colliding more frequently with the wall of the container from inside. So pushing the wall of the container and the size of the balloon will increase. So the volume as well increase and temperature will increases. That is Boyle's law. But they say provided what? Pressure remains constant. Let nobody go on. As the gas inside is trying to push the wall outside. Let nobody go outside and be pushing the wall inside. As you are pushing the wall inside, you are increasing the pressure. The pressure of that around that balloon before is the pressure from the air, which is not strong enough to oppose the wall, the force from within. Am I talking to you? So, but if the pressure is not constant, somebody can just be pushing. You will be frustrating that law. Are we together now? The thing is trying to expand. If we are trying to push, you are trying to push it in. That is why I told you in a filling station where they used to fill gas. You see that their tank, there is always they usually spray water, cold water from tank on the tank to prevent Charle's law from happening because the sun is shining. The gas is expanding inside the tank. Yes. So, but they are putting that water to cool that tank so that the temperature will not increase, so that the kinetic energy of the gas inside will not increase, so that the gas will not be expanding and be colliding with the wall of the tank. Are we together now? So they now say, sketch a graph to illustrate Charle's law. This one is this. We have something like this. This is volume in centimeter cube. This is a temperature. Temperature in degrees centigrade. Now, in this place, you have something like this. Then this is a broken line here. This is minus 273 degrees C. Now, they can ask you, they can give you something like this. They ask you, this minus 273 degrees C, what is it called? It is called what? Absolute zero. Which is the absolute zero is the temperature of a gas when the volume is what? Zero. You know, this point now is only the temperature axis that it touches. Abby? If you touch this place now, okay, this one now is only the temperature axis. The volume is not involved. That means the volume is what? Zero. Are we together? Then we have a question here. Where would I go to clean now? So let me clean here to solve that question. Now, what is the question? What is he saying? He's saying that what? Now, he's saying a given mass of gas occupied, anytime you see centimeter cube, anytime you see centimeter cube, what does it mean? Volume. Anytime you see degree C, this one, temperature. But because they mentioned this one first, it will represent my V1. Are we together? My V1 is 150 centimeter cube. My T1 now is what? Is what? 27. Will I leave it in degree centigrade? I will convert it to what? Kelvin by adding what? 273 Kelvin. Answer will not give us what? Now 293 what? Kelvin. Now, what is my V2? What is my T2? Now, look at this. Oh. They now gave us this pressure and a pressure of this. Giving us a pressure now. It means that it's no longer Charle's law. But it is still Charle's law because we are not going to use this pressure. Why? Because it will remain constant at the end of the day. It's at the same pressure. Look at the end of the question. At the same pressure. It means that the pressure does not increase. It means that P1 is equal to P2. They cancel it Order. Am I talking to you now? So that means pressure is constant. Are you getting it now? That means it is purely what? Charles' law. Are we together now? Now what did they now say? They say at this and a pressure of this. Calculate the temperature. That is the second temperature apart from this temperature. So our T2 is unknown. What is that going to do for T2? Temperature at which is volume. What was his volume before? 150. His volume will be what? Doubled. What is the double of 150? So the volume is no longer 150. It's now what?
300.
So our V2 is now what? 300 centimeter cube. So write our this thing. That's going to be V1 what? Over T1 equals to what? V2 over what? This should be the formula for Charles' law. Are we together now? So now let's put down. What are we looking for? We are looking for T what? 2. Let's cross multiply. Cross multiply. Now when we cross multiply, we have V1 T2 equal to T1 V2. I'm looking for T2. I will divide both sides. Both sides by what is standing with, which is V1. Standing with what I'm looking for. I will now say V1 T2 over what? V1 equals to what? T1 V2 over what? V1. So this one cancels. I have T2 equals, what's my T1 here? My T1 is 293 times what? V2, which is 300 over what? What's my V1? 150. Well, I can say 150 here 1, 150 here 2. So T2 now is what? 293 times 2 is what? 5 what? 586. What's the SI unit now? Kelvin. Because the SI unit of the one we use here is also what? Kelvin. So this is where we are stopping. Thank you. God bless you and bye, Gary. Did you cover this well like this?